Hello and welcome to this video. I've got a Raspberry Pi build head laying around. It's laying around for quite some time, and now that the prices for the Raspberry Pis went down, I wanted to make a review. But for that, I wanted to get a realistic experience, so to say, of the head. And for that reason, I wanted to use it in a small project, which got a bit bigger in between, but more to that later. First of all, what is a Raspberry Pi? Simplified, it's a mini computer that's on one single chip. It's a little bit more powerful than the EV3 and it also uses Linux. And then there's an official build head to connect Lego powered up devices to the Raspberry Pi. The advantage of a Raspberry Pi is that it has more computing power. That means if you want to do complex calculations, you can use a Raspberry Pi with more power compared to a Lego powered up hub. It has more networking abilities, like it has an Ethernet port, it has Wi-Fi, it has Bluetooth, and also has USB plugs. But there are also some disadvantages. First of all, for the build head itself, there are only 4 powered up plugs. That means that you can only use 4 powered up devices without some major headaches. And secondly, it seems to be made to be only used with a plug and with no batteries, which means that for my test project, I wasn't able to do a vehicle because a vehicle would need a portable power source and the Raspberry Pi build head needs to be plugged into the power outlet. Of course, you can use batteries, but that makes the project even more complicated. But back to the project. Another idea of mine was to do an old clock, but that needs power for 24/7, which I didn't really like. And I think that it would get on my nerves after a while because it's loud and it will turn all the time. So I decided against that idea. And I took a look at a second hobby of mine, which is to watch movies.
Ich, Amarendra Bahubali, werde die Menschen von Mahishmati schützen, ihre Gesundheit, Sterblichkeit, Würde und Reichtum.
I've got a digital library for movies or of movies from DVDs and so on. And the movies are on a network storage and different devices can play them with one movie player software, which is named Codi. That way I have to store them only in one place on one device, but I can use it with multiple devices. Like if I want to watch a movie, I can use a bigger screen, or I can use my computer if I want to watch them alone, or I can watch them on my tablet, in my bed, wherever I want basically. And it also has additional features like a music library and a live television playback option. Additionally, Codi can be controlled over the network, and it doesn't matter if it's the Android version of Codi or the Windows version of Codi or the Xbox version of Codi. Basically, they all work the same way. And that's the purpose of this project. Instead of a classical remote control, I built a remote control with the Raspberry Pi build head, and a LEGO Dimensions toypad. As a reminder, LEGO Dimensions was a console game where LEGO minifigures were placed on stands which could be scanned with a USB portal, and then the minifigure that you just scanned, or to be more precise, the stand that you just scanned, could be used in-game. There were official figures like Michael Knight, Sonic, Batman, and some Harry Potter and Lord of the Rings characters, but LEGO made also additional licensed sets for many additional franchises which weren't in LEGO Dimensions, like Spider-Man, Avatar: The Way of Water, and many Disney characters. And for this project, I also put some non-Dimensions figures on LEGO Dimensions pads, and then I could program the Raspberry Pi so that it reads the different figures. Theoretically, Disney Infinity's figures are also supported by the LEGO Dimensions portal, but I didn't try that because I don't have them. And it only works with the Wii U and PlayStation variants of the portal. The Xbox consoles use different portals, so you can't use their Dimensions pads. They're not compatible with the software. So that's the special thing about this remote and the idea why I built it. But for a proper remote, there's also some functionality missing, and that's what I used the build head for. It's there to enable classical control elements. Like I built a play pause button that uses a spike prime force sensor. I used a medium linear motor from Boost, which can be used to change the TV channel, and the motor can be turned by hand, so I can measure the angle, and then the angle can control the channel. And there is also an angular motor to select what you want to see. It's basically a switch with multiple steps. One is for movies, one is for music, one is to watch TV, and one is to listen to the radio. And there's also a secret fifth step for trailers and music videos. And the switch moves back to the correct area if it's turned too far. All of these elements are mounted to a LEGO Technic plate. Then there's an additional description with letter plates. I think that they're from some LEGO Friends set. And then there's also the dimensions pad on top of that. And there are some side walls, and then there's a Raspberry Pi inside. And that's basically the build of the complete project.
Ich bin der gestiefelte Kater. Heilige Guacamole. Hey, Reset. Willst du was Cooles sehen? Gracias. Die Legende wird niemals sterben.
The more interesting part is the code, and the build head can be used according to the official documentation. For the dimensions pad, I used some parts of this musicfig library. It's also licensed under the MIT license, so this project will be licensed under the same license as well. I will link the source code in the video description. And basically there's a class somewhere here to use the LEGO Dimensions pad. I modified it a bit, and that's what I used for the software. The modified dimensions pad class is this one. I simply imported it because the contents of that isn't so important. What's important is how I used it. And apart from the setup, there are handles for the LEGO build head things, and there's a loop to control the dimensions pad. And there's some additional setup, but that's basically the code structure. For the simple control elements, like there's also always the sendle. For example, in this case, it's for the force sensor, and if it gets pressed, there's a network command, which is issued to the player device, which can also be selected with the channel selection. We'll do that later. So if you press the button, basically the Raspberry Pi sends a CURL command over the o.system command, which includes the stuff to the IP address of the device. And the action is play pause. So if it's pause and you press on the button, it starts to play, and if it plays and you press on the button, it pauses. It was also pretty complicated to find the correct commands and so on, especially for later things. That was basically the most complicated part of the project, because I didn't find many example projects. So I had to figure out many things on my own. But yeah, that's basically how this works. For all of the things the remote can do, a CURL request is done to the player, which isn't the Raspberry Pi. Like the Raspberry Pi is in the network, and the player device is in the network, and the movies are in the network. And then the player device can access the movies, and the Raspberry Pi can send commands to the player device. And depending on what the Raspberry Pi sends, the player device will start to play the movie from the network storage. Then there's a handle for the release case, but that's not interesting. There's also a handle for the channel switch. Like that's this rotation thing to change the channel. that it gets turned in one direction. Either the channel that's selected is basically the next channel in one direction is selected, and if it turns into the other direction, the channel in the other direction is selected. But if the selected input is not equal to 2 or 3, and then another remote IP ID is selected. So on the top here is a list of IP addresses, and if movies or music are selected, the IP address can be selected with this channel switch handle, or with the channel switch, and then you can select between all of the IPs in this structure. Then there's also the input select button, and for the music and the movie things, the only command that's issued is that the current playback should stop, because movies are started in another way and music is started in another way. If it's on television, first the current playback gets stopped, and then there's a short sleep command. If this isn't here, the software on the playback device gets very unstable, so it's wise to always stop the playback before sending another command to play TV or radio. And basically after the stop command, there's the command to start to play TV or to start to play radio. And there's also, for the secret command, there's also the stop action. And this is if the device or if the selector gets turned too far, it gets back to the position. Then there's basically a function for some color fading, not very interesting. The more interesting stuff is in this while loop, because I've got a table which is called text.csv, and it's basically a table which contains the IDs of the different pads that can, or of the different stands that can be put on the dimensions pad. And then for each tag, I've got a matching movie ID and a music ID, and an extra for the hidden feature, a third ID or a third IP. And the IP address is basically, for most of the media, it's a network address like SMB, then an IP address, and then the URL. And if, for example, movies are played, then they can be simply started or played with this play.open command. And then there's a file path which can be played. The file path is this SMB IP address and then the network path ID. So that's pretty simple to play movies. What isn't so simple is to play music, because music is stored, or I wanted to play an album and not just one single music track. And albums aren't single files, and only single files can be played with this file play open file command. So for audio, I needed to use the item directory command, and there we have a musicdb path, and this path lists all of the albums, but not the album names, but an identification number for the album. And this identification number is different for each Codi installation. So I had to find out the album identification number previously. It's also possible that there's a better way to do this, but this is the one that I found and it works. So I used this one, but again, there's not much documentation on the more complex stuff of these JSON commands. So there might be a better way. But anyways, so to play an album, first the Raspberry Pi requests a list of all the albums with the name and the identification number as a JSON list. Like this, it's the reply to this command. In this case, I didn't use OS system, but subprocess.open to get the reply. And it's again a curl command. It's basically this get albums command. And then it returns, or then there's a reply of the player with all the album names and the IDs. This is put into a JSON list. and then it gets or the Raspberry Pi searches in this JSON list the file path, which in this case is the album name, and then it can find the ID of the album for the file name, and the ID gets put into this player open directory musicdb thing. And that's basically how this program works. Now to some final thoughts. This project did what I wanted it to do. I could test the build head, and I also did something which would be much more complicated with an EV3 because of the interfacing with the dimensions pad and the network interfacing and so on. But to be fair, this project is very bulky and it's very unpractical also because of the size of the dimensions pad, so I probably won't use it in the future. An idea for the future would be to put NFC tags into DVD cases and then build a simple or smaller scanner for to start the movies. That avoids wear on the discs, but you would still be able to browse your physical collection of DVDs, and then you can simply take the case and put it onto the near-field communication reader, and then it would start the movie. But that doesn't have much to do with Lego anymore. So that was it for this video. Thanks for watching, see you in the next video, and bye.